Let's talk about the Schrödinger's cat thought experiment. It goes like this. An innocent cat is placed inside a box by a mad scientist, Schrödinger himself. Inside the box, there is a vial capable of releasing poison, which is connected to a radiation detector. The radiation detector, in turn, is aimed at a radioactive atom. In the next 10 minutes, there is a 50% chance that the radioactive atom will emit radiation. If it does, the radiation detector will trigger, releasing the poison and killing the cat. Contrary to popular belief, it is impossible to predict whether this will happen or not using quantum mechanics. The calculations show us possibilities, and if the probability of radiation emission is 50%, it remains uncertain. In the Schrödinger's cat experiment, there is a 50% chance of the cat being alive and a 50% chance of it being dead. It's only when you open the box and directly observe the outcome that you will see either a living or a dead cat. This strange aspect of the experiment is one of the reasons why it is so popular. What is the cat's situation before you open the box? If you rely on your intuition, you might imagine that it was either alive or dead before you looked inside the box. However, according to the mathematics of quantum physics, which deals with calculations involving radiation emissions, you cannot assert that the cat was either alive or dead. It is simply impossible to know the cat's state before you open the box and look inside. Join me as things get even more confusing. By the way, just a heads up that the Schrödinger's cat t-shirt is now available in my store. It's part of the new collection you can find on our website at usilos.com.br or by clicking the link in the comments section below. And if it's your first time purchasing one of my shirts, use the coupon code LOST10 to get a 10% discount on your first order. I wouldn't wait too long though, as something tells me that the stock here will run out quickly. Click the link below. Quantum physics is much better at predicting experimental outcomes than our intuition, and that's a fact. It provides us with a good understanding of the universe and underlies nearly all modern technology. Essentially, it is the best theory we have to explain reality. However, if we accept that quantum physics is a valid description of reality, we must also accept that, before we open the box, the cat is in a state of being both alive and dead. This concept is known as quantum superposition, where the quantum world exists in multiple states simultaneously. The Schrödinger's cat experiment contains various distinct possibilities that occur simultaneously. In this specific case, the cat is both alive and dead at the same time. This concept of a cat being both alive and dead may seem strange to some, but it captures the main idea behind the experiment. The purpose is to explore how we interpret mathematical concepts of quantum physics to describe reality. Let's delve into the famous thought experiment of Schrödinger's cat, which was published in a 1935 article titled On the Present Situation in Quantum Mechanics. The scenario sparked a significant debate on whether quantum mechanics was a valid theory for the microscopic world. And if so, which aspects of the theory should be considered real, and which are merely useful mathematical tools. The discussion began with the article by the trio of physicists, Boris Podolsky, Nathan Rosen, and a certain Albert Einstein, whom you may have heard of before. In this article, they criticized the nature of quantum mechanics as something that was not realistic. According to them, it functioned mathematically but did not represent what happens in the real world. I actually have a video on this topic on my channel. For example, according to quantum theory, it is impossible to precisely know both the velocity and position of a particle at the same time. You can only determine either the velocity or the position accurately, but not both simultaneously. Additionally, the results of quantum mechanics calculations provide a list of possible outcomes with associated probabilities. This is called superposition, which is exactly what happens with Schrödinger's cat. It enters a superposition state of being both alive and dead. However, what makes the situation difficult to grasp is that these mathematical results, such as superposition, cannot be observed experimentally. When you try to directly observe quantum strangeness, it simply disappears, and everything behaves relatively normally. In other words, when you open the box and look at the cat, the superposition of being alive and dead is destroyed, and the cat reveals itself to be either alive or dead. The trio of physicists known as EPR argued that this is a flaw of quantum theory and that there should be more precise ways to describe the world that bypass uncertainties and probabilities. They believed that a new description of reality, which reveals the hidden variables of quantum mechanics, would allow us to make accurate predictions about everything in the world. Essentially, they were arguing that the mathematics of quantum physics is not realistic and does not accurately represent the real world. In their view, in the thought experiment of Schrödinger's cat, before you open the box, the cat should already be either alive or dead, not in a strange and exotic state of superposition between the two. And there should exist a physical theory capable of showing us which of the two outcomes is more likely. Mathematically summarizing, the strangeness of quantum mechanics was initially seen as a mere bug in the calculations by the EPR trio. However, other prominent scientists entered the debate. In response, a follow-up article by Niels Bohr argued that despite its strangeness, quantum physics provided a realistic description of the universe. According to Bohr, the quantum oddities were fundamental to the theory and essential for understanding the microscopic world. Bohr viewed these quantum strangeness not as a bug but as a genuine characteristic of our universe. He proposed that the cat in Schrödinger's experiment exists in a superposition of both alive and dead states until we open the box, collapsing the possibilities into a single observed reality. Bohr asserted that these quantum strangeness were as real as the cat in the box itself. The famous article that sparked the Schrödinger's cat thought experiment critiqued ideas from both Bohr and Einstein, contributing to the ongoing discussion. Schrödinger's cat thought experiment was not an attempt to explain quantum mechanics in a way that people could understand. Instead, it aimed to highlight the absurdity of debating the reality of different possibilities. Schrödinger introduced the strange concept of a cat being both alive and dead simultaneously to argue for a third perspective. What truly matters is whether a theory accurately describes experimental results. Engaging in discussions about what is real or not in the mathematics is a harmless mistake. Schrödinger makes a valid point: all we can know is the outcome of experiments, whether the cat was alive or dead in the end. We cannot directly observe the bizarre phenomena of quantum physics, such as superposition. According to Schrödinger, quantum theory is excellent because it correctly predicts experimental outcomes. However, this doesn't imply that the mathematical representation of quantum physics corresponds to a solid, tangible reality. As Schrödinger himself stated, reality resists imitation through models. Thus, we must abandon naive realism and rely on propositions that can be observed through experiments. It is senseless to debate the meaning of equations if we can never directly observe them. All we can know is the outcome of experiments compared to the predictions provided by our equations. Physics is best understood from an empiricist viewpoint, where experiments hold authority over theory. Schrödinger disagrees with the realistic perspective held by other physicists of his time, which claimed that theories contain elements of reality. It was an attempt to illustrate a situation that becomes utterly absurd when we think of quantum phenomena as real things. This discussion, symbolized by Schrödinger's cat, represents the debate about what aspects of quantum physics are worth taking seriously and what are merely useful calculations that give us results closest to our real-life experiences. If we think like Bohr, cats can be both alive and dead at the same time. If we think like Einstein, Podolsky, and Rosen, we may completely abandon a very good theory like quantum physics just because we dislike its mathematics. And if we think like Schrödinger, we give up the ambition to fully understand the intricacies of a seemingly complex reality in exchange for trusting experiments that yield undeniable results. This is the often hidden beauty behind Schrödinger's cat experiment. It is not about a cat supposedly being both alive and dead simultaneously. It is an attempt to show that in life, we often encounter theories that make absurd predictions but can still be valid if they align with what we experience in the real world. Perhaps we will never reach a point of perfect understanding of the nature of our surrounding reality, but we can have a good enough theory that allows us to navigate the chaos of the universe we live in. We always ask if the cat is alive or dead, but we never ask if the cat is happy or where it is. Thank you very much, and until next time.